78? All right. Find the area. Oh, okay. So the rectangle they give you is this. Now, in general, what's the area? If I give you a rectangle 7 by 3, what's the area going to be?
7 times 3.
Yeah, 7 times 3. And I always think about like a little ice cube tray. This would be a very freaky little ice cube tray, but 1, 2, 3, 4, 5, 6, 7 cubes that way, and then 3 cubes this way. So how many total cubes would there be? Well, 7 rows of 3, that's going to be 21. So it makes sense the area is multiplying. So you do the same thing here, the exact same thing. So the area is going to be this side times that side. And you just let go of the x. I mean, the x, there's nothing for him to go with. What can go together? Yeah, 5 times 8 is 40. Cool. Good. Yeah, don't worry, everybody always wonders what happens to the x. Well, what does 8 times 5x really mean? I mean, really. And of course, that kind of question, you're never really sure how to answer that. You're like, what
8
that
times
means?
5
8
times a number.
So it means 8 of these, 5x plus 5x plus 5x. So it'd be 5, 10, 15, 20, 25, 30. You just kind of all up. The quicker way to do that is multiply. Right? So the x is just part of what you have 8 of. I have 8 5x's. So I have 40 x's. So don't worry about what the x does. There's nothing the x does. There's no other x for that to go with. That's coming later. Does anybody know what that would be? X times x? X squared. I love it. So if there was another x in there, it just become x squared. Cool. Is that good? Yeah.
I have another problem.
Oh yeah, good.
Section 22, number 21.
Number 21, all right? This one. That one there? Okay. So somebody help me out. What do I do first here? Yeah, multiply through. There's nothing I can do inside here. And real quick, I don't think I've said this yet. And this should kind of bother some of you guys. I don't think I've addressed this yet. And if it bothers you, that's good. I mean, in general, if I had something like this, what does order operations say? Yeah, and what's 3 plus 1? 4, 2 times 4 is 8. Yeah. But if I have this, order operations says, add that. And I can't add that. And I see a lot of people that make this 1x. So addition becomes multiplication, right? So there's some weird kind of multiplication, magician, I don't know. Right? So you got to be careful. Addition can't become multiplication. You can't force order operations to actually work here. So why the hell am I all of a sudden allowed to multiply? Why am I allowed to do that? I can't remember if I put this up here yet. And it should bother you. And there's nothing wrong with it bothering you. Because we make a big deal doing the parentheses first, unless you can't. And then you think, wait a minute. It's got to be one or the other. So what we actually do here is, like I just did earlier, what does 2x really mean? It means x plus x, right? That's the fundamental definition of what 2x means. Don't tell me it means 2 times x. It's still not fundamental. So 2 of these would be x plus 1 plus x plus 1. And then would I not have 2 x's and 2 1's to make 2? So then distribution is just a shortcut. It says, well, screw that. I'm just going to end up with 2 of these and 2 of those. Let me just do it that way. So distribution is really a shortcut. So it's not going against order operations. It's rewriting the problem so it's not multiplication anymore. It's all just addition. And then I can just put those together. You guys with me? So I really, that kind of thing kind of gets in the back of your brain, and you start saying math is just dumb. Number one, there's too much shit in it. I remember it, and then they do shit like this, where they say, yeah, you got it, and then no, you don't really. I mean, so I desperately want to make sure that I don't miss any of that, because it's what makes people lose faith in math. And it does take a little faith at first. It's not a religion, right? But it's just you got to realize why we're able to do certain things. And you should question me when I do something like that. Say, wait a minute, what the hell? And I better have an answer, else I don't deserve a paycheck. Okay, so coming back here, after all that crap, all we do here, like you said, distribute, what do you get? 10x minus 6. Now, I really like the way that this kind of came out last time. I really didn't plan on saying it this way, and I never really taught it this way, but who's in the wrong place? What's in the wrong place?
10x.
Yeah, 10x is in the wrong place, right? The numbers are good. There's no other numbers anywhere, so they have set up spot here. That's where the numbers want to be. So these guys are in the wrong place. They shouldn't be with the numbers. They should be over with the other x's, right? So you find who's in the wrong place, and you put them in the right place. So how do I kill that 10x? How do I make it not be there? Minus 10x. So then here, that goes away. The negative 6 is still here. Equals is still there. 11x minus 10x. 1x. Cool. And then you're done. Sweet, because you got x equals the number. That's how when you know you're done.
Do you always get rid of the x on the left of the...
Doesn't matter. If it would have been written like this, which is really the exact same problem, right? Isn't that the same problem? Then I would subtract 10x. Do you see what I'm saying? So it all depends. The 10x is in the wrong place. I don't care what side of the equation I decide to put that on. All right? The equal sign is like a mirror. It doesn't really matter which side you're thinking about. You can switch sides. They're both the same, so it doesn't matter which side you're on. You guys kind of with me here? So there's nothing specific about the sides got to be where things are. This is the way you must go. No. Okay, cool. How are we doing?
But, I'm sorry.
Yes?
I'm saying is, would you be able to subtract 11x?
Oh, so your question was more, yeah. You could. Now here's the problem. Let's go back to the way it was written. If I subtracted 11x, here's what I always get. Here's what I get. I get this. And then suddenly the equals sign shows up. But you guys kind of follow. This is what I was saying about don't lose anything. Now let me just let you look at that for a second. Because I get this a lot. So people have an understanding, they're just screwing themselves over. You've got the understanding, but it's just because the way you wrote it that's in the way. And that sucks. Math is all, do you understand it? And if you write it wrong, well, shit. You're really kind of putting obstacles in your own way. So really, if I do this, you guys see what I did wrong?
Comes out positive.
Yeah, I totally lost that side. And plus it came out to a different answer than we got.
So it's not an equation anymore because there is no equal sign.
Yeah, I kind of made it not an equation somehow magically, right? Right? You're an equation, you're not. Right? Letting of the hands, and you go, you're not an equation. So that something must be really wrong there, and there is. I mean, now if I followed my logic, there's nothing wrong really with what was done. There's nothing wrong with it. It's kind of not the best way to go because you see how I've loaded down one side and stuff. This has already x's and numbers, and I'm going to throw some more x's over there. Yeah, I'm loading that side down. What's really left on this side?
0.
Yes, let me write over here. So if I do this, Moja, if I do this, I got to follow what I just did. 11x minus 11x is 0. 10x minus 11x, negative x, and the minus 6 is still here.
Oh, and then you add.
Then you can add, or even better, add x, because that would make it positive, and then you're done. If you add 6, you still have to divide by negative 1 to kill that negative. You guys kind of with it? So if I add 6, what do I have? It's gone.
Negative x.
I still have negative x. And you don't stop there. The goal is not to figure out what negative x is. The goal is to figure out what the hell x is. So how do I get x by itself?
Divided by negative 1.
Yeah, kill the negative. It's right now it's a coefficient. That means it's multiplying, so I got to divide. And I get the same damn answer I got over there. just it took me longer. So is it wrong? No. Is it the best way to do it? No. Right? Good. You should. Right? Because it really leads to people making this kind of mistake. The equal sign disappears, and then it's only, whoop, it's back. Any other questions from, yeah? Question?
72, 31.
This is page 167. Oh, yeah. So let's see here. This shape here, 72, 3.1. Only that section. Okay. Oh, you got misnumbered?
Yeah, I started on 1-3, but I was like, I realized when I got done, I was like, I'm gonna be that guy.
Well, don't do it on, but you don't have to redo it. Right? You can turn that in. Just try not to do it too much. Don't be that guy too much.
I won't.
But this one says find the perimeter. So there's no formulas for perimeter. It's just that one idea about add up all the sides. So really this turns into a like terms problem. So they like to show you how the skills we're learning, the like terms idea, leads into all these other things. So a geometrical question turns into a like terms problem, and that's one more reason why you should understand how to put like terms together. Right? There could be sides of something that I don't know yet, but I do know that that's 3 times this big as that side. It's not trying to scale. Okay. So how would you get the perimeter? You just start collecting everything. 5x plus 3x plus x. Just kind of walk around. Plus 7 plus 4x plus 12. You imagine a little dude walking around. He's got a little nightstick. He's on patrol. You don't want the perimeter. Right? I like the look I get from some of you guys when I make a joke. Yeah, Joe. So obviously math teacher making jokes. So now it's just like terms, right? So what like terms can I put together?
5x, 3x, x.
4x, cool. All my x's, right? 5 of them, 3 more is 8, another one, another 4, 13x, and then my numbers, 7 and 12. Bam! So a lot of times in mathematics, we apply an idea. How do I find the perimeter? Add up all the sides. And then I apply the procedure. What does math say? How does math say to do that? I have an idea, and then I have a procedure. The idea of perimeter is always add up the sides. The procedure is now like terms to actually get that done.
I'm just happy because I got it right.
What's up?
You
Oh.
looking over here, I'm like smiling.
I know,
I'm just happy
that-
'cause I got it right.
I don't see smiles as often as I like to in math class. Well, it's time to get this. Anything else? Yes. I'll work that way. 42 in 3-2. The sort of reminds me of the one we just did that I just erased. Was it 10x? This is 42. This one here, right? Cool. Doesn't this, the one I just erased here, it looks a lot like this one here? Because it's got x's on both sides. So who's in the wrong place?
X.
The x. Right? Because the numbers are all together, so I shouldn't have any x's with them. All my numbers are together. I got to get my x's on the other side. He's in the wrong place. How do I kill him?
Minus x.
Minus x.
9x.
Negative 63
9x.
equals
9x.
9x. And then
Divide by 9.
divide by 9. Cool. X equals, well, you know, I often do that. I'll just turn it around in my head because personally, I just like the x on that side. I'm kind of used to it. You don't have to. But if we just follow it straight down, this is x, and this would be
Negative 7.
negative 7. Yes, ma'am.
So you need to subtract x on both sides.
Oh, sure, yeah, yeah. You can subtract and add any damn thing you want to both sides of an equation. I could add 83x to both sides right now. Would that be a smart thing to do? No. Could I do it? Yes. I could do any damn thing I want, add, subtract. I could divide by any damn thing I want except 0. Right, that would freak it out. Is that cool? So a lot of you guys are realizing you're kind of getting the equation solving, but you're still having trouble with putting together like negative 11x plus 6x. You're still having some trouble with dividing things or something. I mean, that's always, you got to keep firming that up. Because you're never going to be able to progress very far if that's always holding you back. Yeah.
Number 6 on 3.3.
Oh, actually, let me work this way real quick. Sorry. I got these two guys. 57? 3.2? And some of you guys might want to adopt this way to make a T. Over the years, my T's used to look like this, but they very quickly became curved so that I could tell they weren't plus signs. Right? So this problem here, right? So, yes, sir.
I was just curious, would you have a problem if we ever changed, like, whatever the variable is to, like, just x?
And I'll tell you this, I don't have any problem with that as long as at the end you bring back in what the original variable was. And it seems like a small point, but later it's going to become huge. Because this could mean time. Or you know, somebody could just be an ass and say, I didn't ask you a damn thing about x. I asked you about t. You know? So as long as you bring back the variable. So what Marco's saying is, could I rewrite this to be this? Yes, and I want to make a point right now, early in your math career, as long as you bring back the original variable at the end. I have no problem with that. Yeah. Okay. So what should I do first here? Combine those, yeah, okay, cool. Combine those. Right, I always look at both sides to see if there's anything I can do on either side. And there is. What's 7t minus 12t? Negative 5t, yeah. And now I got one step left to do to get the t by itself. Divided by
5.
Negative 5. So the negative 5 cancels. What's 10 divided by negative 5?
Negative 2.
Negative 2. So you get negative 2 equals x, and you just read one more thing, negative 2 equals t. Because me, I don't like the letter L or T, or yeah. So I agree with you. I replace it with something. Z, exactly. Z always looks like 2, and then suddenly 2z becomes 22, and the whole thing goes to L. Any other questions? I think you have, yeah.
39, 3.3.
All right, so what's the first step on this guy here?
6.
Yeah. So whenever you see those parentheses, just hope you guys hear that too.
You're what?
See, no, that would be me. That would be the smartass in the So yeah, you're always drawn to the parentheses. You're already naturally drawn to them because it's the very first thing in order of operations. So thank God it works out for equations. So I want to bring this, 42x.
Minus 6.
Good.
Minus 4.
Yes. You see how this looks like we've done this like 3 times already. This is the same exact equation for the 3rd time. I know there's different numbers up there, and I don't care. The same equation. These guys are out of place. Subtract them over. Yeah, negative 6 equals
X.
X. Done. In fact, that's the same answer we got just a minute ago. That's great. Yes?
24 on 3.4. 24.
24. I like the way you guys naturally ordered yourselves by section here. Oh, we haven't really done word problems yet. We're doing that today. Yeah. Well, who else? There's somebody I had to skip. Yeah.
72 and 32.
7232. This one here.
Yeah.
All right. So again, what's the very first thing we can do? Yeah. So we can distribute the negative 4.
Negative 4x.
Minus 28.
Good. Negative 28. I like it.
Minus 30.
And what can I do on this side?
Negative 34.
Yeah. So put the 3 in minus 37. Subtract 37 minus 3 is 34. The bigger one's negative. On the other side, is there anything I can still do?
Applying negative 28 and
Yeah, put those together, the negative 28 and the negative. They're the same sign, so you add them, put the sign back on. So that's there, this is there. Equal sign is still there, the negative 34 is still there.
58.
I'm going to keep doing that, because that's the biggest mistake people make. I can see you understand it, and then you lose something, you're not careful enough, and then that's the only reason you make a mistake. So now, I'm sorry? Yeah. So now, what's out of place? These guys are cool. These guys are out of place. They should be with those. So I kill them on this side by doing the opposite. Whatever I do to one side, I have to do to the other side to maintain the balance. Indiana Jones. So here, I got my negative 4x is still left alive. Equals,
On this one,
good, 58 minus 34, 24.
24.
X equals
And that's the answer of the day, it seems like. Because the last step here,
dividing.
yeah, right now it's negative 4 times x, so I have to divide to kill it. Don't do this, by the way. Does that make any sense? If I did that to both sides, my variable would be on the bottom. That would so suck. So just divide by what you don't want. X is, yet again, negative 6.
Someone like really would like negative 6.
It's freaking me out. When in doubt, negative 6.
That was 42.
Yeah, it is 42. That's not when in doubt. That is the answer. I just don't know what the question is.
There you go.
I suppose there's 6 times 9.
Oh,
Oh, yes. Any other questions on homework? I love you guys. Okay. So, the last thing we have to do here, we still have to finish out chapter 3, that's section 3.4. I don't think, okay. So since we just did a bunch of questions about solving equations, I'm going to treat that as my little review. Hopefully everybody's gotten part of the way, at least through chapter 3. It gave you an extra day. It was nice. Decided to get sick, gave you an extra day. So we are going to get into word problems. And I can completely understand why word problems gives everybody trouble, because it's we saw a very tiny example of this earlier, and even that kind of gave us some trouble. What I mean is this: can you write 8 more than 3 times a number? What would that look like in math?
3x
Yeah.
plus 8.
I like it, and I always write it like that. Like, you know, if you wrote like this, you're not wrong because you can add either way you want to. But that kind of keeps you on track. If it would have been instead, if it would have said 8 less than 3 times a number, that would have been 8 less than 3 times a number. So when I see this, I actually say to myself, okay, 8 more than 3 times the number. And that's how I put it together. Personally. Yeah. All right, so that was actually our first little foray into what you need to be able to do for word problems. Now, word problems adds an extra step in. Word problems does not give us kind of like the beginning point. We have to figure it out ourselves. And here's what I mean by that. Oh, actually, let me do something a little more interesting. You feel comfortable telling how old you are? What's your name again? Dimitri. Well, that makes you feel old, but Demetria is 13 years younger than Jeff. How old are each of us? Don't say anything out loud. How old is each? Oh, that's
What does that
teach
say?
you.
Add what?
Add Jeff's age to Dimitri's age, and you get 67.
What are their features?
I like writing. Demetria is 13 years younger than Jeff. How old are each of us? So here's where you start with the word problem, right? Now, a lot of these word problems, you can actually probably figure out the answer without doing any algebra. That does not prove that algebra is useless. What that means is we're giving you easy word problems to start with so you can kind of feel more comfortable trying to work the algebra in. So it's kind of nice to know the answer ahead of time, but then you have to figure out, okay, how do I set this up in algebra so I can tackle the really freaking complicated problems I'm going to get in 90 and 110. Right? They're not always going to be something I can kind of tease out. The first step in any word problem is, what are the players? Right? The first step is actually very English related. And when I read through this, do not even care. You should, the first time you look at a word problem, don't care about 13 years younger, don't care about 67, don't care about any of that stuff. Just the pure English, how many things are involved in this problem?
Jeff and Dimitri.
Jeff and Dimitri, 2 things, right? So you write down here, so step 1, Jeff's age, just to be a little more precise, and Dimitri's age. So there are 2 things involved, and that's what they are in English. Now we need to write what they are in Mathish, because English is not well set up to handle getting solutions. English is well set up to explain situations. So to explain a situation, I need to translate into math so I can get the solution. You guys kind of with me? A little bit? So what do we know here now? Now, who would I have to know the age of first? And then I can do what this says to figure out the other person.
Jeff's.
I'd have to know my age first. I could tell that Dimitri's age depends on my age, because we know that Dimitri's 13 years younger than me. Cool? It's not cool actually at all. Getting up there. Some of you guys are laughing at me, I know. So the second step is always, which player is just going to be X? Somebody's got to be just X.
Jeff. Jeff's gonna be X.
Jeff's got to be X. Because Demetria depends on it. So if I call my age X, I can then write a math expression for Dimitri's age. She is 13 years younger.
X minus 13.
Since I set up my age as X, I can now write Demetria as X minus 13 years old.
I think it's a 17.
Oh, it looks like a 17? It's supposed to be 13. Sorry. It did look like a 17. The number 3 doesn't agree. You guys kind of would be in the idea at least. Let's get past the 3 or the 7. Does that kind of make sense? I mean, math is all about, okay, you don't know what it is, so we're going to call it X for right now, just so I can work with it. We know how to work with X. X and 2X is 3X. X, I can divide out. I know how to work with X. I don't have to work with Jeff's age. If I put that into an equation, there's too many freaking letters. So we call my age X, therefore Demetria must be X minus 13. Because she's 13 years younger. And then step 3, so step 2 was setting these guys up. And then step 3 is write the equation. What are those two things supposed to do? Very often they do something together.
You're supposed to add them. Right.
You add them and you're supposed to get
67.
67. Right? So if I do X plus
X minus 13.
X minus 13. So you add my age to Demetri's age and you get 67. You guys kind of with me a little bit? Not really at all? You guys are like, what? So you guys are like, just tell us how old you freaking people are. You understand? But I really desperately want you to, the beauty of algebra is, when I say how old am I, you don't currently say you don't know. You say X. You are X years old, Jeff. Oh, good. So algebra is kind of like pretending for going, we know how old I am. Well, I'm X years old. So you're X minus 13 years old. And if you're 10 years younger than me, you're X minus 10, so forth. I mean, we know how all of our ages is in mathish, right? Now I've got the equation set up, I can do the solution. I can get the solution. Now that I've got it fully in math, I can solve it. So how do I solve this equation?
Two like terms.
Yeah, get like terms together. 2x.
Gotta get the 13 on the other side.
Yeah, do what to both of them?
Add 13.
Add 13.
Divided by 2.
Divided by 2. Now, you don't just stop here and circle it and move on. That's not good enough. X is 40, I don't care. The question is, how old are we? So who was just X?
Jeff.
Jeff. Jeff.
It's 40.
It's 40. The more I say that, the worse. Jeff is 40 years old, and Demetria is 27. 40 minus 13, 27. Now, I mean, I just created that problem. There was no need for this problem to exist in the real world. But just to illustrate how to solve a problem, we need this. In the real world, somebody doesn't know the answer. We go, what is it? We put it in, now you guys solve this. No. In the real world, we don't know what the hell it is. We observe, we write down our observations, we make equations, and then we try to figure out what's going on. I mean, that's the real world, right? We don't know what the answer is. How could I check the answer real quick? You could ask us. But let's say that we both go away. How could you check them?
Plug
We're
40
supposed to
in
do
and
what? These two numbers are supposed to
Add to 67.
add to 67. They do. That kicks ass, right? Now, obviously, if you got Demetria is supposed to be negative 4 years old, I would hope to God you wouldn't just put that and keep going. Step out of the math for a second and make sure it makes physical sense. Don't tell me that you need negative 8 feet of wood to build this hill. What the hell kind of wood is that? What planet is that from? I got negative 8 feet. What is that? I don't know. All right. Just make sure your answer makes sense. Don't tell me she's not born yet. All right, let's try another. Certain rectangles length. 8 feet. Or twice the width. The perimeter is 46. Find the dimensions. Make sure I did that right in my head. Yes. Now on this one, anytime you have something geometrical, obviously over here, you could have drawn us. There's Jeff, and I'm not even going to try to draw me. But you don't have to draw anything. Now if there's a geometrical problem, you should draw the picture. So I call that step 0. But sometimes you have to do it. You're talking about a shirt on sale for 20% off, don't draw a little shirt and help you. But if I'm talking about a triangle and the perimeter or the area, then obviously draw yourself a picture so you can kind of see what the hell's going on. So I have a rectangle. So we're going to come back to that in a second. So I drew it. Yay. So step one, what's step one? It's not a good box.
You got
Okay, good. The width. So figure out who the players are in the problem, right?
length and
How many
width.
players are there? Length and width, 11. Don't say perimeter. Perimeter is where the equation is going to come from. That's what length and width do together, right? So the two players in this problem are the length and the width. Now again, the same thing we just did over there. The great thing about this is you start to see, thank God, that not every word problem is a new thing. You can always attack it with the same steps. The first step is very English related. Just tell me the words. Tell me, use the exact same words they do, but write what's involved. Right? The length and the width are involved. Now we start to translate into math. Which one of these is going to be just x?
Width.
Wait.
Why?
Because the length depends on the width.
Yeah, the length depends on the width. I love it. That's how you tell. And that's probably the most important step. If you miss that step, you're screwed. Everything else is wrong. Right? So the width has to be x. You can even call it w if you want to. Let's do that. W. Now you start to see why it's not always x. If I'm talking about time, I want to use t. If I'm talking about cost, I want to use c. So, you know, why not? So if I'm talking about width, call it w. What's the length now? I like it. 8 more than twice the width. Cool. Doesn't matter. Not really. I'm going to try to slowly get you guys to do that way. How are we doing so far? Now, the biggest mistake people make on this problem is they don't go all the way around the picture. If I write this as my equation, the perimeter was 46. Can anybody tell me? I basically just gave it away, but what is wrong with that? It's not exactly the same as that one where I just added the things I got together to get a number.
2 lengths and 2 widths.
Yeah, I didn't go all the way around. Here's W, here's 2W plus 8. I went halfway around. That ain't going to work. Right? It's not going to be 46. I only went halfway. So there's actually 2 ways to take care of that. And let me just say the first way is just to go all the way around. Right? Here's W again. Here's 2W plus 8. So I should say W plus 2W plus 8 plus W plus 2W plus 8. Just to go all the way, W, then get all the way around, and that will be 46. Cool.
Just double each of them.
Or you can just double each of them. Exactly. Cool. And now you combine this. Now, just to say on the side here real quick, you could, if you do W plus 2W plus 8, that's halfway, so that should equal 23. If you think about that, that's cool. But in general, you can just always do this for a rectangle. Right? And what you're saying is you could actually write it's 2W's plus 2, 2W plus 8.
No. Yeah.
2W's plus 2W plus 8. You could actually do that. They're both the same thing. Right? Okay. This is sort of right now a step backwards in a way. What do I get when I put all my like terms together here? Let's try to be a W. Yeah, W, 3W, 4W, 6W, good?
That's 16.
Good, 8 and 8, 16. All right, here's where we see if Jeff made a problem that works in his head. Let's see. Yeah, subtract 16. The 16's in the wrong place. It's with all those letters there together, so it should go away. 6W equals
30.
30. And divide by 6. W equals 5. Again, just to go back, don't stop there. And in fact, here we got to be a little more careful. Over there, I should have been a little more careful too. But width is 5 feet. So what's the length? The length will be 2 times 5
10
plus 8,
18.
18 feet. And how do we check ourselves? Well, 5 plus 5 is 10. 18 plus 18 is 36. 36 and 10 is 46. Thank God. It works. Right? And again, if you get -3 here, do not circle it and keep going. If you can't see what you did wrong, at least write, I know it's not supposed to be negative, but I'm not sure. At least, don't tell me the side is -3 feet long. How do you feel so far about that? Is that, you kind of see where that's going? Let me give you this here. And then I'll set up a problem for us to try. This is my attempt to help your notes out for this section.
Thank you.
You're welcome. All right, let me let you look that over. There's no problems on here, by the way. This is just examples. Let me find us a good problem. So try that one. Step one for you guys is, are you able to translate Jeffish to English?
Jeffish to Mathish to English.
Jeffish to English to Mathish, yes. So go ahead and try to get that one going. See how far you can get with that problem there. And trust me on this. Those of you who try to speed through the problem and you don't do the steps are the ones who will make the mistakes. Trust me. In fact, I'll show you on that problem the most common mistake people make that don't do all the steps. See if anybody experiences that personally. gotta be careful. Got something. You actually made a mistake I was just talking about. No, together they're the tractor is 7 times the time. The plow must be X. And that's what you have to add them together. You leave an X out if you skip the steps. It's right on the player's out. Oh, so first step, don't skip steps. First step is just write in English what the plays are. So in this problem we got
The tractor and the plow.
beautiful tractor, plow. Okay, cool. So underneath there, which one's going to be just X? Which one does the other one depend on?
Yeah.
The tractor is worth 7 times as much as the plow.
So the tractor.
So which one would you have to know first, and then you can figure out the other one?
How much the tractor is? The plow?
Because it's 7 times the plow. So if I knew what the plow was, if I knew the plow was $100,
Okay.
I 7 times 100, $700. So I've got to know the plow first. Put an X there. So the plow is X. Now what's the tractor then? It's worth 7 times as much. So if the plow is worth X, and the tractor is 7 times as much, 7 times.
Oh.
Yeah, exactly. So now what does it tell me? Together they're worth that much. So what do I do with these two? And you're supposed to get, there you go. See, that's where equation comes from.
Put it backwards.
You try to have both of these in there, it looks like, or I'm
You
not
just
sure.
labeled them that way.
Gotcha. But then she left this guy out. And that's actually the most common mistake. Good to listen. All right, guys. We try to catch up to you. You see now, the minute you're not just watching me do it, it gets a little bit like, holy shit, wait a minute. Right? But this is where you do not skip steps, especially early going. At some point, you'll get more comfortable with equations. You can skip some steps, no problem. But right now, do not skip a single step. First step, don't draw a tractor and plow. First step, I just gave it away, but what are the players here? Tractor and plow. So write it. The first step is English. I think for some reason, students think that they're supposed to be able to just write the equation down after they read the word problem once. Or, and this one I can kind of understand more, you don't want to waste freaking time. You're like, I got other homework to do. Let me just write something down that kind of comes from that, and let's just keep going. Right? And I understand that. But what the hell sense does that make? You're wasting time because you're going to get it wrong. So, first step, purely English. I don't care about any of the freaking numbers. I don't care about the 7 times. Tractor and plow. Second step, start to step a little bit in the math. Which one has got to be just X because the other one depends on it? Yeah, the tractor is